in example 9, we have denominators everywhere. We have an x plus 1 in the denominator, we have an x in the denominator. This 5, if I wanted to, I can write it as 5 over 1, and then we have this denominator over here. Gosh, so what are we going to do? We've got multiple things in the denominator, and I want to clean this all out. Okay, so to find your LCD, the first thing we want to do is make sure everything's factored. Well, x plus 1, that's factored, because it's just x plus 1. X is by itself, it's factored. Let's go to this one right here. We can actually factor that because there's an x common between both those terms, and that's going to leave you with an x times x plus 1. So really this problem is 3x over x plus 1. I'll leave myself some room here. Plus, and we got 2 over x, and then plus 5 over 1 equals, and then on the right we really have 3 times x plus 1. Okay, so let's figure out what this LCD is. What's common here that we can multiply all these by so we can eliminate the fraction? Well, if you have anything unique, you always throw it into the LCD. So see, x plus 1, that's unique, so I'm going to throw that into the LCD. Just an x by itself, not necessarily x plus 1, just an x by itself, that's unique. So I'm going to throw that in there. 1, not so much. And look right here, x times x plus 1, that's already in there. So there's our LCD. It's just kind of, when in doubt, just multiply everything together. So I'm going to go to each of these fractions. I'm going to multiply it by x times x plus 1. X times x plus 1. X times x plus 1. And here, x times x plus 1. And I'm kind of writing it up here in the top because we're really just multiplying the numerators just like that. Okay, well, let's go through and let's start reducing. The x plus 1 in the front is going to cancel with that denominator, leaving you with just an x times 3x. Next one, the x is going to cancel with the x, leaving you with an x plus 1 times 2. Down here, nothing's really canceling, so we just have an x times x plus 1 times 5. And then on the right, the x cancels with the x plus 1 with x plus 1, and we get 3. Look at that. We had the correct LCD because everything went away. It's all down to one level. So let's just start cleaning this up. We'll have 3x squared plus 2x plus 2 plus, let's see, if I multiply, let's see if I can do 2 at one time. Let's say 5 times x together is 5x. So 5x times x is 5x squared, and 5x times 1 is 5x equals 3. Well, at this point, because I have squares terms in here, I have a quadratic, and the only way I can solve my quadratic is if I move everything over to the left side and put 0 on the right. So let's do that. So pretty much that means just move that 3 over and make it a negative 3. And combine some terms here. So 3x squared and 5x squared is 8x squared. 2x and 5x is a positive 7x. I have a positive 2, but if I go ahead and think about moving that minus 3 over, so 2 minus 3 is a negative 1 and then equals 0. Alright, so again right here, if you want some more practice on quadratic, go quadratic. If you need the practice on factoring, factoring. No matter what, why don't you go ahead and pause the video for 2 seconds and let's see if we get the same answer. And then when you've worked it out and tried it yourself, then push play and see what we get. Okay, I went ahead and factored it to 8x minus 1 and x plus 1. And so when I set each one of these equal to 0, if I move for this 8x minus 1 equal to 0, if I move the 1 over, it becomes positive, and then divide by 8, so 1/8. And the next one, x plus 1 equals 0, just move the 1 over and we get negative 1. Okay, so again, because the original problem had variables in the denominator, we got to go back and check our answer. Let's just do this roughly. If I put 1/8, 1/8 plus 1, definitely not 0, so that works for that first fraction. 2 divided by 1/8, well, you're dividing by 1/8, and that's not 0, so that works there. A 1/8 squared plus a 1/8, definitely not 0, so that's working out nice and perfect. Let's go throw negative 1 in here. Go to the very first fraction. Let's look at that denominator. What's negative 1 plus 1? Hey, look, we got a 0 going on. Not going to work out. Even though, look at the second fraction, 2 over x. If I put a negative 1 right there, it works out for that one, and that's fine. Let's even go to the right side. If I do -1 squared plus a -1, well, -1 squared is +1, and a +1 and a -1 is going to put a 0 on the right as well. It doesn't matter. If it only puts a 0 in one spot, that's all that matters. It does. I mean, if it fails just even one time, you have to throw it out. So this is what I'm going to look for you guys to do, is go ahead and list them both. If you want to go ahead and box them both, great. But then go back and mark out the one that doesn't work so I can see that, oh, you took the time to go back and check your answer. Okay? All right, now let's go on to example number 10. With this example, we're kind of going to go back into the world of radicals that we talked about initially in 1.6 and 1.7. So if we go to our steps on how to solve a radical, remember that first thing it said is you had to isolate the radical, and it's not isolated here. It's just it's the square root of 3 minus 4x, and we have this plus 2x. So to isolate it, we need to move this term over. So we have the square root of 3 minus 4x is equal to now a -2x. Okay, and just so far, it's been exactly what we just did before, in the sense of just isolate it, and then what we're going to do is we're going to square both sides, because to get rid of a square root, we're going to do a square. Okay, so squaring the square root cancels, those two are just opposite operations of each other, so you just get what's sitting below it, 3 minus 4x. And let's look right here. I want to square a -2x. So if I wrote it out, it's saying -2x times -2x, right? So I need to make sure I take the time to not only just square x, I got to square that number in front. So it's a 4x squared. And this right here is why we saved this problem for this lesson, is because we're in a quadratic. We have an x squared term. In 1.6 and 1.7, everything on this row was all linear. It was just x to the first power, but now we have a quadratic. This is obviously my leading power because it has the x squared. So I'm going to move these two over because we have to set it equal to 0. So I'll have my front term being positive. It's easier for me. You could choose to go the other way. You're going to get the same answer. If I move a -4x across that equal sign, it becomes a positive 4x. And then 3 across the equal sign becomes a -3. Okay, and at this step right here, if you want to do quadratic, go quadratic. If you want to do factoring, go factoring. No matter what though, pause the video, get some practice on your own, and then let's come back and check what we get to the same answers for both, whichever method you chose to do. Okay, well I factored the 4x squared plus 4x minus 3, and I could have chosen for that front of each of the parentheses, I could have done 2x and 2x, or I could have done 4x and 1x. I chose to go 2 and 2 just because I knew I was working with some smaller numbers. And then the factors of -3, I put a positive 3 on the left, on the right one, and a -1 on the left. So when you check it, the outside gave us a positive 6, inside's -2, so that's definitely the positive 4. Okay, setting each of these equal to 0 and solving it out, I get an x value, moving that 1 over becomes positive and divide by 2, so 1/2. Moving the 3 over, so it's -3 divided by 2 is -3/2. All right, and just like we did in 1.6 and 1.7, anytime you're working with a radical, you always need to check your answer. So let's kind of tentatively, all we're going to do is just throw it underneath that square root sign. Let's make sure it comes out positive. So 3 minus 4 times 1/2. Is that going to be positive? Is this greater than 0? Okay, it could be greater than or equal to. It just definitely can't be negative. Well, what's 1/2 of 4? Well, 1/2 of 4 is 2. So the square root of 3 minus 2 is the square root of 1, which is definitely greater than or equal to 0. So that one checks off. Let's go to the next one. Square root of 3 minus 4 times a -3/2. Is this greater than or equal to 0? Is just that part of that radical. Okay. Well, 3 plus, let's see, 4 times 3 is 12, and 12 divided by 2 is 6. Right there. I don't even have to go any further. They're both positive, so obviously it's definitely greater than or equal to 0. So that one checks off. So we can actually keep both answers in this case. All right, let's go to the next example, number 11.